Hello everyone, welcome to Part 5, Decorators. Decorators are an advanced tool in Python, and I want you to feel free to skip this lecture and come back to it at another time. Since we won't actually encounter decorators until much further on into the advanced Django material, it might make more sense for you to skip this lecture, and once you encounter decorators in the Django sections of the course, come back to this and review decorators. Otherwise, you may find yourself understanding the syntax, but being a little forgetful by the time you actually reach the use case of decorators. Okay, so again, we leave this lecture in this section because material-wise, it makes the most sense to leave it here. But as far as using it in this course, I would recommend that you actually skip it for now and come back to it when you see decorators mentioned again. Alright, with that all being said, let's get started. Okay, so to start off with decorators, they can be thought of as functions which modify the functionality of another function, and they really help make your code shorter and more Pythonic. And they're also used a lot in Python web frameworks, especially Django and Flask. Now, you don't actually run into decorators in Django until much further along in your learning of Django. But to properly explain decorators, we're going to be slowly building up from functions. So let's break down all the steps. First, we'll start off with a very simple function review. Remember, if we want to create a function, we can just say def, the name of your function, any parameters you want to pass, and then you can say return, for instance, the number 1. And if I want to call this function later, I just say func. And if I want to print something, I can say print func. Okay, so if I save this and I run this, hopefully by now you have no problems with this. It returns 1. It all makes sense. Now let's discuss scope. So also remember from the scope lecture that I have global variables and local variables. So if I have the string s, global variable, and I save this, and then inside of this def func, I say something like take in s, and then I say print s, and I save this, and let's say over here, I just call func, func with s, excuse me, and then I run this, I get back global variable. And now, if I don't provide s as a parameter to the function, and instead do this, and run this again, it still works, because here, I don't have anything in the local namespace called s, so I jump back out and look for the global variable namespace for s, and I still find it, so I end up printing global variable. Now, if I redefine s to be equal to 50 inside of this, save this, run this, I get back 50 when I call function. But if outside of this, I call print s, save this, I get back 50 global variable. Remember, if I actually want to reassign not just the local variable s, but instead the global variable s, I have to say this, global s. Then I save that, run this again, and note back now I get 50, 50. So actually calling that global keyword calls in and tells me to affect the global, not just the local variable s. And there's actually a way you can grab a dictionary or a list of all locals variables and all global variables. And the way you can do that is inside of this function, just say print and then call locals. So locals returns a dictionary. Whoops. Locals, close parentheses. We're going to save that, and then I'm going to call the function here. So I can save this, run the code, and note here right now I have an empty dictionary because I don't have any local variables defined here. If I do define something like my local to be equal to 10, save this, run this, and now I see my local is 10. So that's just a convenient dictionary call to actually grab the local variables. Now if I say something like print globals, this will print out all the global variables, and there's going to be a lot here. So if I say python notes.py, I get this huge function of global variables. And that's because, not function, excuse me, a huge dictionary of global variables. And that is because there are a bunch of built-in things. So even though we haven't defined a whole lot yet, there are a lot of things. So there's notes.py is a global variable for the file. S here we saw is a global variable string. So I can also just call this like a dictionary. So globals, remember it's a dictionary, so if I call the key for s, and let's hashtag that out, I run this and I get back global variable. So printing globals at s finds this key value pair. Okay, so now that we remember what globals and locals are, let's start by continuing on with functions and function assignment. If I have a function called hello, and it takes in some parameter name, we'll have the default value be Jose, and I'm going to return hello plus whatever name is provided. And let's say I call print hello. I save this, run notes.py, and it says hello Jose. And we can put a space in there so it makes a little more sense. Now I can also assign a label to a function, meaning I can say my new greet and set it equal to hello. And note that I'm actually setting it equal to the function itself. I'm not setting it equal to what the function returns. I'm not doing these parentheses here. I'm setting it equal to the function itself, which means I could say this, my new greet, close parentheses, and print this out. So let's do that. Let's print out my new greet, save this, run this code, and I see now I have twice hello Jose. Once from hello, and then since I define my new greet is equal to hello, I also get my new greet. And now that we understand how we can assign functions to new variables, let's continue on with functions within functions. Hopefully so far everything seems sort of like review. Now I'm going to create a function called hello again. It takes the default parameter name, Jose, and right off the top in this function I'm going to print the hello function has been run. So if I ever call hello, I can see that the hello function has been run. So that makes sense so far. Now, inside of def hello, I will define another function. And I will call this function greet. And what this does, it returns, note it returns, it's not printing, it returns something that says this string is inside greet. So if I run python notes.py, I shouldn't expect anything else to be different because I don't actually call greet, I just define it here. And I'm going to do one more that says def welcome, and this returns this string is inside welcome. And we can save that. Again, if I run this code, I shouldn't expect anything different to happen because I'm only defining these functions inside of this function. I'm not actually calling them. Now, and pay attention here to the indentation. With the same indentation, let's zoom out a little bit so we can see all of this. So with the same indentation still inside def hello, what I'm going to do is say print greet. And then I'm also going to print welcome. And I'm going to say print end of hello. So now if I save this and I actually call the function hello, note back, I get the hello function has been run, I get the string is inside greet, so I actually define greet and call greet here, and then I define welcome and also call welcome, and then I get end of hello. And remember, because of scope, I cannot call greet or welcome outside of this. So I cannot say, whoops, I can call hello, but if I try to call welcome outside of the scope of this function, and you can quickly check what's inside this function by just collapsing that entire function here. So I run this, welcome, I will get an error. It says name welcome is not defined because welcome is only inside the scope of the hello function. So keep that in mind. All right, so that's the basics of functions within functions, and I promise this will build up to decorators. Now let's talk about returning functions, something we haven't actually seen yet. So let's say this. Inside of my hello function, I will say if my name is equal to Jose, we'll put in lowercase Jose, return greet. So note here, I'm returning a function. We haven't actually seen that before. And then I will say else, return another function. We'll return the welcome function. I'm not saying return the call of welcome function. I'm saying return the actual function itself. meaning it's returning this entire function, not just the string itself. And now I will say this. X is equal to hello, close parentheses, and then I'm going to say save this. If I run python notes.py, all I see is hello function has been run, but I don't know yet what has actually been returned. So I can do this. X, close parentheses. If I run that, it says hello function has been run. And because this was just a return string, I need to actually print this out. So I can say print X, run this, and now it says the string is inside greet. So again, let's break down what's happening here. I'm saying if the default name is equal to Jose, which is the case, if name is equal to Jose, return the greet function. And the greet function is this entire thing. And the greet function just says, in itself, return this string. So then I set X equal to the result of hello, and by default the name is Jose, meaning I'm returning X to be equal to greet. So this is the exact same thing as saying X is equal to greet, except if it was happening inside of this function. So remember X, hello, and then I can call X, since it's now greet, and print out its result, which is this string is inside greet. Okay, really take your time with this one. This is kind of one of those jumps that might be a little confusing at first, but it's actually not so bad. Again, we're just returning a function, assigning it to a variable, and then calling that variable's function, and printing it out because it returned a string. Now we have one last concept to go over before we actually talk about decorators, which is a function as an argument. So I'm going to delete all this code and say def hello, and it will return hi Jose. And then I'm going to create another function, we'll say other, and it's actually going to take in a parameter func. And then it's going to print hello, and then it's also going to print func. We'll save this, and I'm going to pass in a function as an argument. So I will call my other function, and I will pass in the hello function. And keep in mind, I'm not passing what the hello function returns, I'm passing the function itself. So I don't have open and close parentheses at the end of hello. So if I run notes.py, I get back here function hello at this, which means if I actually run this inside of the other function with close parentheses here, now I should see hello, hi Jose. So again, make sure you really understand what's going on here. I'm passing in a function as an argument, and then inside of the other function, I can call that function. So again, here we can see we can pass in function as arguments. Just like we could pass strings, numbers, dictionaries, etc., we can pass in functions themselves inside of another function and then play around with them. And now it's time to actually show the basic steps to create a decorator, which has to do with all of the concepts we just covered. So in the previous example, we essentially manually created a decorator. So let's show it and modify this to make it really clear. I'll create a function called new_decorator. And this takes in some function. And then inside of this function, I define another one that says wrap_func. Doesn't take any parameters. And it's going to print code here before executing func. And then here I will execute func. And remember, I can call func because it's in that namespace. And then after that, I'm going to print func has been called. And then outside of all this, I'm going to return wrap func. And then I'm going to create a new function called func needs decorator. And I'm going to have it just print. No, it's not returning, it's just printing. This function, if I can spell, is in need of a decorator. So let's start off with a simple example, which happens when I call func needs a decorator. So if I just call that run python notes.py, it says this function is in need of a decorator. That makes sense so far. But what happens if I actually reassign it to say func needs decorator is equal to the new decorator with func needs decorator passed inside of it? So if I run this and then call func needs decorator, save that, run python notes.py, it says code here. Well, let's actually expand this a little more. It says code here before executing func. This function is in need of a decorator. Func has been called. So what happened here? The decorator simply wrapped the function and modified its behavior. And all of this code can be rewritten with the @ symbol. So again, what's happening here is mainly all in line 13. Remember, I have this original function that needed a decorator. It just does a simple print command. And I'm now passing it as an argument inside of new decorator. And inside of that, I'm calling it inside of this wrap function and returning that wrap function. And all of this can be done with the @ symbol. So let me show you what that actually looks like. I can say here, instead of these lines, so I will actually just comment this out so you can compare. So I have the func needs a decorator equal to new decorator with the func needs a decorator. Instead of that sort of reassignment, I can use the @ keyword and type in the name of the decorator I want, which is @new decorator, and then call a function, the func needs decorator. Well, I can actually call it, I would basically type this entire thing. So we can just grab this special keyword, that @ keyword, and this is the same thing as doing this. So now if I call func needs decorator, save this, and I'm about to run this, but remember what happened. I said code here before executing function. This function is in need of a decorator. Func has been called. I run this, and I get back the exact same thing. So the key point of all of we talked about is this, that if you ever had a situation where you would need to pass a function that needed a decorator into a new decorator and then reassign it, that's all going to be done with this simple @ call. So the new decorator with this @ symbol call is the same as doing this. And that's all we wanted to get across. Now you might be wondering, when the heck am I ever going to need to do something like this? Well, it's not really clear now, and it won't be clear until we actually show you an example with Django much further along in the course. But hopefully you actually watched that already and came back to this because you were confused on what the heck we were doing with the decorator. And I hope now this made it all clear. Okay, thanks everyone, and I'll see you in the next lecture.